Hello everyone, welcome to your next section. Today we're going to be talking about a new type of while loop, which is a while loop. These are different than for loops because rather than like taking an object and running through every element of an object or every character like we learned with strings, lists, and dictionaries, while loops will continue in iteration so long as a conditional statement remains as true. So what you're going to learn today is you're going to learn how while loops work, but you're also going to integrate some of your knowledge from a previous chapter on if statements and conditional logic to build while loops. While loops are really useful, although they can be kind of finicky and a little bit dangerous if you don't know what you're doing. So, because for loops have some sort of definite end built into them, because once you're at the end of your object or list, they will stop. However, with a while loop, because it's a conditional statement, unless you build in some code that allows your while loop to finally break, it can loop for infinity. So I want to spend a little bit of time teaching you about for loops and pitfalls there, as well as some things regarding how to create decent while loop logic. So in this class, you're going to learn what while loops look like, how that iteration process goes, as well as some suggestions for how to build your while loops without making them break or do stuff that you wouldn't expect or like. So what is a while loop? A while loop is an iteration method that will iterate infinitely until a certain condition has returned as false. So usually when you build your while loops, you're building a condition that is currently true and then building out some additional logic so that it'll eventually turn false. So with that in mind, guys, let's look at the syntax of a for loop and show you how we build the language around it, but also I want to spend a little bit of time showing you how that infinite loop can occur in the syntax before we jump into code and deal with it, okay? Okay, so we are here. Okay, so here we are. This is a very simple example right now because I want to illustrate a couple of concepts in writing. First and foremost, let me just get the right pen here. Here we go. Okay, so the first thing we do is I'm initializing a variable because I want to initialize something that I can build a conditional statement around. And the syntax for a while loop is generally quite simple. So all it is while, you write the word while, and then you build some sort of condition that needs to be true in order for the code that is indented within this while loop to run. So in this case, we have our while, and our conditional statement is I is less than 10, and then we end our conditional logic with these colons here. So remember that maybe we have additional pieces of logic. It's important to have these colons here because what if we wanted while I is less than 10 and, I is an even number, which we could use modulo for. 0. Oh, equals 0, not double 0. It was double equals, not double 0. And then in order for Python to know that this is all done, that's when the colon comes in. So the colon is really a period, almost like a period on a sentence that tells Python, okay, the next stuff needs to be indented and I'm only going to run this stuff on this set of code. In this example, guys, remember how I said that you need to build logic for your while loop to break? At the moment, this condition will stay true infinitely, meaning that I can never be greater than 10 with the code as we have it now. And what will occur in this case, if we were to run this code, is that Python would just print looping infinitely, meaning that it will never stop. It'll just print looping thousands and millions of times if we let it. So it's really important for us to build in logic that is going to break this, all right? So how we do that is make this I statement eventually greater than 10. So we can do that by using I plus equals 1. And so every time this iterates, it's going to print looping, and then it's going to add an incremental number here. So I is now equal to 1. Then it's going to loop again, and it's going to go I is equal to 2, all the way until I equals 10, and then it'll break out of this loop, okay? So that is all very important because with a for loop, you kind of have your breaking features already built in for you. But with while loops, you have to build it yourself, and it's contingent on your conditional statement. So there's no like one size or one trick fits all situations for your while loop. You need to really have a strong understanding of logic and how to break out of that logic if you need to later on. Okay guys, with that, let's run into a terminal and play with while loops in Python proper. Okay, so here we are guys. First thing we're going to do is initialize our little variable here, and we're going to play with what I wrote before. So while I is less than 10, so remember this is the syntax, we use the while command, we then give it a conditional statement that has to be true in order for this while statement to continue to iterate. This is definitely true because 0 is less than 10. We're then going to just print looping. And that's it. So what will happen in this case is we're probably going to end up with an infinite loop. And I want to show you what an infinite loop looks like because I don't want you to be scared of them. So I press enter. We are definitely in an infinite loop here. As you see, it's printing looping so fast that my cursor doesn't even show up on the screen for like recognizing that it is in fact still looping. It's just so fast. So if you get caught in an infinite loop in Mac, how you break out of your loop is by holding the control button and pressing C. And that does a keyboard interrupt. It'll be a similar command in Windows. You might have to press Control Alt or Command or something like that, but it's probably Control C if memory serves. And that will help you break out of your infinite loop. What happens now if we add some logic to this while loop so that we can break out of it and we'll see what happens. So I'm going to include I in this print and now do our I plus equals. Now, this is something I didn't show you earlier, but this is kind of a shorthand for this. I plus 1. So usually, if we wanted to, increment a variable, this is very common in a lot of other languages. This is the syntax for how you do that, because currently it's at 0, so it'd be 0 plus 1, and that adds to I. But a shorthand in Python is that you can do I plus equals, and that is effectively doing the I plus whatever value you want. So I'm just doing that as a shorthand so you guys can understand how that works. And what do we expect to happen here? Mostly the question I want to ask you is, what should I be at the first iteration, and what do we expect I to be at the last iteration? Do we expect it to be 1 to 10 or 0 to 9? Well, it's 0 to 9, and why is that? Well, we got to think of this iteration here, this loop in general. So when we first enter this loop, I equals 0, and we haven't incremented yet. So it says print looping, I now becomes 1, and then it goes back to the iteration. It checks if this statement is still true, and then prints it again, which now equals 1, and then increments the 2. So by the time we get to looping equals 9 here, it's now going to increment one more time and equal 10, and now that I is greater than 10, this now returns as false. Even though I is actually 10, it only printed 9 because it broke out before we printed again. Does that make sense? Okay, so with that, guys, I want to also just show you an additional thing about that additional and or logic we were talking about before. So with while loops and for when you're dealing with any conditional thing, so in while loops and if statements specifically, you can chain conditions together. So first, let's also just make I back equal to 0. We do while I is less than 10 sometime, and I mod 2 equals 1, then we want to do something. And usually it's a good idea when you're chaining these kinds of conditional statements together to wrap them in braces so that they don't mix up what is true and false here. So this will determine whether this is true and then this is true, and if it's an and statement, both need to be true in order for this to break. So you do that and print looping I and I plus equals 1, and it doesn't break. It fails because the first thing that happens is it checks if I mod 2 is equal to 1. It is not equal to 1, so this whole while statement is actually false at this point. So what if we did something like while this, or this might actually infinitely loop, because one thing, well, it won't infinitely loop, but one thing is going to be true for a while. So let's see what we got here. Oop, print looping. Ah, that's what happened. I didn't give it a quotation. So we have the or here, print looping, and then I plus equals 1. And see what we get. So it does also break at 10. Why though? Because once it hits 10, it's or. So this now is false, and this now is false. Okay? All right, guys, with that, let's just do a recap. So we learned about while loops. We learned about how the syntax of a while loop works, how that we have to consider how we break our conditional statements so that we don't get caught in infinite loops. In the next section, I want to spend a little bit of time with you guys putting all of this learning from chapter 3 and 4 together. So we're going to do like a for loop and embed some if conditional statements and make a Python script, or a Python set of code run that is dynamic and can do different things based on what elements are coming into the for loop and what conditions have to be met in order to do some different operation on that element for each iteration. So this will be the last lecture in this chapter 4.5, and I'm looking forward to seeing you there.